Hello, everyone. Thank you for coming. I was afraid no one will come because of the lunch break at the same time, but so happy that you grab a bite and find time to join me. I'm Marta with SubQuery. I work as a tech evangelist there, and I'm here to tell you a bit more about indexing data from Cosmos with SubQuery. I'm based in New Zealand, so it was a long flight here, but totally worth it. We are extremely happy to connect with builders and zones in Cosmos, as we believe this is the ecosystem to be at. And the whole mission of SubQuery is actually to speed up the internal growth of Cosmos by providing tools that the app developers can use to get data from blockchain in an easy way, and then focus on functionalities they want to develop, right? So let's get to it. I will talk a few words about the problem that we are trying to solve with SubQuery and give you a quick overview of SubQuery solution, and then we will get to the coding part where we will index some data on osmosis, swap routes, and pool entities. So first of all, let's have a few words about the problem SubQuery solves. So blockchain is not the perfect place when it comes to data query. So it's perfect for storing data. However, it's not very efficient when you want to get data from it. The blockchain, we use a bit of this metaphor. Blockchain is like a book, right? If you really want to ask any question, actually, to get the complete answer, you have to read page by page by page. It's not very efficient. And modern applications, they need their data fast. They need their data quick to present to user fast. No one waits for anything anymore, right? So this where SubQuery and other tools that help with indexing come to provide this solution to be able to query data in a faster way. And then another problem that some of you may encounter is actually the complexity of the whole ecosystem, right? So we have a lot of zones in Cosmos, and the number of them rapidly grows, which is absolutely great. We want to see that. But with every zone, it comes something specific to the zone, right? And there are chain tags, protobufs, specific, unique for the zone, API protocols, or standards, and then it's very hard if you want to index data cross-zone to use it within one project. You have to solve this. And as a app developer, that could be one of your problems that SubQuery wants to help with. And coming to solution, or like the summary of the problems, we really want you to save time and not develop your own indexer if you don't have to. Of course, you can. It's not a rocket science, but it takes some time, up to weeks of development, depending on what you are going to index. And you can rely on a solution that is provided by us. We've been working on SubQuery for 2 years already. We have a huge team of developers who are working on the indexer. So not a lot of people have the same amount of resources that you can contribute to developing indexer, right? So this is a solid solution you could use. And also, we are solving the issue not only from the query speed problem, but also for the cross-zone indexing. And the last thing is you can even forget about production infrastructure for this indexer, because you can host it with us, and I will tell you more in a sec. So just to give you a quick overview of what SubQuery is, what SubQuery does, is like an open source tool that allows you to get data from blockchain, transform it within your application so that the data is presented to your user as you want it to be, and query it to power your application. You can think about SubQuery as like custom API, which will work seamlessly across all the zones, Ethermit and Cosmos based. And when we've been designing SubQuery and also maintaining it, we had like four principles for sure. The fast. It has to be fast, right? Performance is super crucial, so we work constantly on optimization of it. It has to be flexible. This has to be a tool that the developers can take and do with it whatever they need, so it's tailored for their needs. And we kept a robust flexibility of it. Has to be open source for sure. What we want to do is to help others build, and we don't want any limits to it. And it has to be universal. So that was our idea, to make sure that this tool allows you to index data cross-zone, but also beyond Cosmos ecosystem, across different layers one. So we support currently, apart from Cosmos, Polkadot, which is our mother ecosystem, but also Algorand, Avalanche, Near, Flare, Ethereum, BNB, Polygon, and more probably, I don't know, but gradually we'll be adding support of more of ecosystems. So this will allow you to get the project once ready and then be able to index data across different ecosystems, not only within not only from different zones within Cosmos ecosystem. So this is pretty powerful. And other features that can be of interest for you is, of course, we support most smart contract languages, execution languages. As I said previously, you can write it once and then run it everywhere. So here we are to discuss Cosmos and gateway to Cosmos, right? But as I said, it works beyond Cosmos. It's performant. We provide also so GraphQL API, so it's very easy to query. A lot of people are familiar with GraphQL, so it should be comfortable for them. And reindexing, also we introduce a lot of features to allow developers to reindex data fast if this is needed. And it's quite portable. You can connect to any RPC endpoint, so it truly should be absolutely adjustable, flexible, and you can tweak it to your needs, and that was the aim. That was our goal. Okay, so we also aim to be the leading indexer in Cosmos. We support currently, I think here we have 13 zones, but today we announced 14th, which is Comdex, and by that I mean that we provide a boilerplate starter projects for all of the zones here, which means that builders that want to index data from those zones can, with few clicks, access data from the zone and have the boilerplate project ready, which is super easy, like 1 minute and you can already do it. And gradually we introduce more and more support. So if you are coming from one of the zones, hit me up after the talk. We need few things from you, like chain types, protobufs, and we can do this support and help your builders also to index data quickly. So very proud of all of that partnership. And today we will index data on Osmosis, but we could do it clearly on any other zone listed here. So a few words about our customer verticals. So we have a lot of explorers native to Polkadot actually that are using SubQuery to get the data. And this is interesting because that's a vast amount of data, right? Chain explorers, chain scanners, they have to know everything, and they rely on SubQuery service. We also have DApp developers, we have blockchain devs, so different people, different projects from DeFi to NFT marketplaces, bridges, you name it, right? So no matter what you're building, you can use SubQuery Indexer to achieve your goals and get your data. And to look at the SubQuery project in a nutshell, so we have like 3 files that usually we want to focus at. So GraphQL schema file, that's the place where you define your entities in the database. I will show you this file in a sec. And project manifest, this is the configuration of the SubQuery project. This is the place where you define what and where you want to index. And then the last one, mapping files, this is the place where the magic happens, right? You get data from blockchain, you transform it, and you save it in the database. So we will go step by step. We will see every file, but this is the most important part of SubQuery scaffold project. Okay, so let's now see it for yourself. We will see some code. Just give me a sec. And now, so what I want to show you first is actually show you how you would use SubQuery CLI. And before we go to this, I just want to mention that for SubQuery, you need Node, Yarn, and Docker, right? So basic setup. And of course, SubQuery CLI. So for this, I will just say, is it big enough? Well, let's see. SubQuery init, and I just want to show you how you would work with it, or your builders if you're coming from zones. So as I said, we support different networks, but we are here to talk Cosmos. And here are the zones that we support. So just I will quickly go to Osmosis because this is our focus for today. And then I just press enter, and we have to wait for a little bit. I hope network works. The Wi-Fi, it should. Okay, so anyway, what should happen here is that we should just define a few things like RPC endpoint, description. You see, we have to wait, but it's here. So a few things, but if we don't provide it, there is a default answer to it. So no worries, the project has been downloaded. It's on my computer, and then I want to show you how it looks. So we will start with schema GraphQL. I already mentioned that this is the file where you identify and define entities in your database. And this is a good place to actually start looking at SubQuery project because it shows you what you are after, like what you want to index, right? And this is a classic example that I want to go through with you. We will index all swap transaction on Osmosis DEX, and we'll do it step by step. We will have 3 different tables in our database, the swap route, and pool. On Osmosis, you have different pools that are like liquidity pools between assets. So if you want to do a swap, usually what can happen is that there'll be multiple steps. So if you want to swap, for instance, Osmosis token to let's say Juno, then you will go. It can happen that it will have multiple steps touching different pools. So you will swap from Osmosis to Injective, from Injective to Atom, from Atom to Juno. So what we want to index here is not on. We want to make sure that we get all the swap routes because that's interesting. So that's why we have table of swap, table for a swap route, and of course the pool. And between them, you can see foreign keys and connections in between tables. And this should reflect, of course, the data structure and how you want to present it within your application. So basically, this is the schema GraphQL. And the next file that would be good to look at is our manifest file. So this is the file that I mentioned is like a configuration of the whole project. This is the entry point to your project where you discuss what and how you want to index. And the top part, it's not that important, of course, like title and description and so on. But where we want to focus is actually network and then data sources. So for network part, of course, when you want to index anything, you have to have chain ID. So here we are on Osmosis 1. And then endpoint, we need that. So we are using onFinality endpoint for it. And dictionary, that's optional, but recommended because it significantly speeds up indexing process. So we are using dictionary here. And what you need is chain types, right? Specific for a certain zone. So here we are using some of the Osmosis chain types, protobufs, but also focusing on a specific message here that we want to actually use, the filter that we want to use for our message that we want to index. So this is a message swap exact amount in. And here, if we have a different boilerplate projects for different zones, we would see the difference in data, right? So different protobufs and chain types for specific to certain zone. If you would like to use SubQuery for to index data from a zone that is not supported yet, you would alter the code here in that particular spot. So that's definitely doable. And if we would look at SubQuery project that index data from Cosmos, but also from different layer ones, right, like Ethereum or Polygon or Polkadot, we would see several different data source types and also different chain types. So this file would grow. But here we are focusing on Osmosis. We have this classic example, so we go forward with it. And then data sources. So this is the place where you define what you want to index, not from where, but what exactly. And we started at this height block because this is exact height block of when the Osmosis DEX started. So this is what interests us here. And this commented code here, I think it's huge enough, right? We see it clearly. Shows the 4 methods that actually can be used with SubQuery. So we have handle block handler that allows us to do whatever we want on each block. The same with similar with handle transaction. We can index everything that is connected with transactions happening on the chain. And we have also a handle event, which we could use to get all the data related with event token swapped. But for this workshop, we decided to go with a handle message because it's a bit cleaner. And what happens is that every time, so we go through the chain from this block height until the latest one, and every time we encounter a message with of this type, message swapped exact amount in, we will run our indexer and get this data, right? So we are focusing only on this part of the whole entire data on chain, which makes it super efficient then for our application, because we don't have to ask for everything. We only focus on what we want, right? So that's the brilliant idea behind it all. To if we can to index only what we want. So this is the overview of the manifest file, and now I want to show you the third one, which is mapping handlers. So this is the file where the magic happens, right? So just going back here, this handle message handler, it matches up with the function in mapping files, right? So every time we encounter this message on chain, we will run function, which is in this file, and it matches exactly the name of the handler in the manifest, right? So this is handle message function. And what happens here, we received Cosmos message, and we actually imported some types from Osmosis package to ensure type safety. And also that's why it's in TypeScript. So what happens in that part of the code is that we receive the payload of the function, that we have the message from the chain. And first thing we'll do is to actually log it, report that it happened, so the function was revoked. And then the next step what we do is to construct object of swap, and then you can clearly see that this reflects exactly the structure of the swap entity in schema GraphQL file, right? This is the same thing. It has to be built in the same way. And going back to mapping files, what we want to do is to save the swap entity in our database. And before we in the whole process, we also want to process all the swap routes that I mentioned, right? Because for a single swap, what can happen is there was only one swap route, but it could be multiple of them. So what we need to do is to ensure that we got them all. So what we will do, we will run it through an array of swap routes, and for each item in that array, we will first check if the pool exists, because every swap route, it belongs to a pool. So to avoid any issues in database, we just do this check. And then we construct the object of swap route with all the information needed. We, of course, the pool ID is there. And then we push this into the array, and then we go through this array for each swap route, and we save the whole swap object at the end. So this is it. This is how this works. This is a bit like, it's a simple project to show how SubQuery works, but you could go farther with it, right? It's very, as I mentioned, that it's flexible and customizable, which means that in this moment of the project, in this place, you could do a lot more. Like you could call to external APIs for more data. You could interact with contracts. You could use some custom libraries here. Actually, sky is the limit. You could do whatever you want in that moment and already impact the data, right? So for instance, in our situation, what we could do is to let's check, for instance, the predictions of the token swap on CoinGecko, and then compare if whatever we are doing now on Osmosis will give us the end result, which would be similar to the value in USD dollars of the token that is predicted by CoinGecko, right? So that just something that comes to my mind. But of course, sky is the limit, as I said. So there is a lot we could do here. And then what happens, right? So we have this project, and what would we do with it? What would be the next step? So we would run it with Docker, and I'm saving it for another time to avoid Docker hell. Sometimes Docker can be a bit tricky, and you don't want it when you do a live presentation. So what I did is I deployed the project on our managed service yesterday, and it's fully synced, and we will show it. We will see how it all works using our managed service. But usually you have it locally, you run Docker, and what happens is that indexer is connecting to the chain. There is a Postgres database where everything is saved. So we have an indexer connected to chain. We have a Postgres database. And what we also have is we provision the GraphQL API for you to be able to query this data from this database, right? So this is how it would all be structured. And now what I want to show you is actually maybe one thing more, which is cool. Let's see the mint scan, because I forgot about it. Let's see the JSON message here. I search for routes. Okay, so we have them. See? So this is, for those who are not familiar with Osmosis and this data structure, this is something that we are after here. So we wanted to index all the swap routes, and here we see we had Osmo token, and here we have IBC. So going back to our code, we've discussed everything what's needed here, and now I will show you how it would work on our playground on managed service. So just give me a quick, okay, so this is our project here. So this is the thing that I deployed yesterday. And now I want to show you how the query looks and how we can get the data from our database. Here is one of the queries that I used previously. This is for this project. So what we could see here is that we want to see the most popular pools, 5 most popular pools, and they are based on the number of swap routes, right? So we can see that the first one with ID 678, this is the pool, which is the most popular in terms of the number of swap routes, more than 3,000, right? And of course, this query here, we can custom it. This is simple, right? Just do the 10, but what else you can do is actually go to the documentation here and check all the docs, all the possible queries that are available for this particular project. And the developer experience, if you would run it locally with your Docker, would be quite similar. So the whole playground we provide, it looks similar to this. It provides also detailed documentation. And it would be, by default, accessible at 3,000 port on your local host. So this experience would be pretty similar. And I have I think 2 more queries that I pre-saved for us to use. So let's see this one. This query shows the most complicated swaps that happen on Osmosis based on number of swap routes involved. Okay. So we see that there were 6 of them. For all of them. So it means that the number of swaps, which is the highest on Osmosis, number of swap routes on Osmosis is 6. Okay. And then maybe one more. The largest swaps made by token in amount. Let's see. Okay, so this is the token in amount for the largest one, and then the second large is quite smaller, right? So this is how it would look in terms of the very high overview of SubQuery project. And let's go back to our presentation now at this stage. Okay. So I want to tell you, before we finish, I want to tell you a few words more about SubQuery, just to end up our conversation here. So as I said, you can host it locally. It's completely open source, but you can also rely on us in terms of the hosting service. You can run projects for free. You can run more of them if you run more, there is a bit of a payment to cover our service costs, but you can rely on us in that term as well. And here there are some links to our managed service and to SubQuery Network page, so feel welcome to check it out. And the really interesting part of all of that, and to tell you a bit more about SubQuery, alongside SDK and the tool that I showed you, we've been building a SubQuery Network, which is like truly decentralized network where you can participate to index data, to delegate indexing, to consume data, so you can be delegator, consumer, or indexer. And we are happy to say that we launched our pre-mainnet network, Kepler, and here is also the link to check this. Actually, I can maybe show you. So just a sec. Here, for instance, on Polkadot, if we go to indexers, we can see already it's live, and we have people indexing data within the SubQuery network, which is absolutely awesome, and it's a big thing for us, big milestone. So we're happy to share it with you. And then going back to our presentation, just to finish, thank you so much for coming along. Please hit me after this chat. Of course, there is time for questions, but I'm here for the whole Cosmos Gateway, and I'm happy to connect with all of you. So don't be afraid to reach out, and also join our Discord community. We have a very live Discord community with a very live also technical support channel, so any questions there are more than welcome, and we have a lot of ambassadors, and also we are there to help people build. And yeah, don't forget also to write to me. I'll be happy to connect with you and answer all the questions that you may have about SubQuery. And many thanks for showing up, many thanks for coming. I'm happy to see such a big room, especially during lunch break, right? Thank you, guys. And ladies, not only guys, okay? If there is any question, I'm happy to answer. Yes, hi.
So the whole thing is open source, and you can run it on your own.
Yes.
But you need to select RPCs, like you need to find them.
Yes, you need to find either, yeah.
And what about your managed service? Like if I rely on that, what RPCs do you use? Do you run your own node?
No, so yes, so then it's on us. Then you don't have to worry about that. And or it can be provided by you. Sometimes we have that. Like there is a great RPC endpoint that can be used. It would be also good to have archive node, which is unpruned, to make sure that we have all the data that we may be interested in. So sometimes it can be provided by the customer, right?
So you don't have like archive nodes there?
No, yeah.
Do you have so I was saying, I'm not sure what is already supported, but if I want to, let's say, feed a custom data, is it possible to feed a custom data?
Yes.
Okay.
Yes, it is, yeah.
So not even from the node directly, but I can feed something else as well.
Process data. Yes, you can. Yes,
right.
Yes, you can. You can feed. You can upload data from different data sources if you need, and then yeah.
So what's your solution if I mean, this would be the same solution. Let's go do let's say initial import of the state. So let's say I start now, but I already have my existing state, and I would load it and index it. Do you support that already, from the get-go or not?
I'm not sure. I can back to you. I can get your answer after the talk to your question.
For example, the easiest way would be if you are able to import the genesis, export the genesis, and then basically feed it into.
Let me double check to make sure that I give you the proper answer. Let's just hang around after, and then yeah.
For the decentralized network, is that functioning as a marketplace essentially for independent?
It will, yeah, it will. Yes.
And are there services verifiable on chain, or is it kind of a trust relationship?
Well, they are verifiable. All of it is verifiable. And currently, we have a test pre-mainnet network. There are also rewards included in Kepler SubQuery token. But then in the future, when we launch the whole network, it will be SubQuery token as well, and it will be verifiable.
Cool.
Hi.
Is it possible to catch different entities, not only messages, for example, events?
Yes. So we have handler, event handler, transaction handler, block handler, and then message handler for Cosmos. So, and then all the filters, like depending on the data shape on chain itself, we can filter through that. But we have handlers that are tailored for those objects, right? So I just went from message for this particular project, but it doesn't mean that it has to be related with message only. Okay, cool. I think that's it. Thank you so much. Really appreciate you. Okay. Thank you. Awesome.